All right, now we can put the limit definition of derivatives behind us and find them the easy way. Now, the first one everybody seems to learn is the power rule, and that's just what to do in the case of polynomials. You know, x to the first, s to the second, x to the fifth. We'll actually cover roots in a different video, but this is all about powers of x. Also, I want to point out that there's a lot of vocabulary, different words people use to refer to derivatives. Differentiation means taking the derivative. So if the directions on a problem say, hey, differentiate this function, they really just mean take the derivative, which, as I've noted before, y prime is the derivative of y. Same thing as f prime is the same thing as dy dx. Same thing as d over dx means, hey, take the derivative of this. The x down here means take the derivative with respect to x, but we won't get into what that means. You don't really need to care about that until the chain rule, which of course every calculus student hates. Most common question I get, that's when people first call tutors, is like, they kind of got by in calculus until they saw the chain rule, and then it's like, bam, let's pull the plug and get some help. So here we go, the power rule. What's the deal? Basically what this formula is saying is if you want to take the derivative of x to a power to an exponent, you're just going to take the old exponent and put it out front, because notice how that just ended up out front as a coefficient, which is kind of wacky. And you're still going to have x, and then the new power is just going to be one less than the old power. So real quickly, derivative of x squared, which we've actually done a couple times now in calculus. We just take the old power and move it out front, so this 2 comes out front. Then we still have an x, then the new power is just 1 less, which in this case is 1. And of course, a power of 1 we don't bother writing, so that's just 2x. And you may recall that in an earlier video, we found that same derivative using the limit definition of derivatives, which you may recall was quite painful. All right, next one, x to the fourth. All we do is we take the 4, drop it out front, so we get, y prime I should have said, equals 4 times x, and then the new power is 1 less, which is 3. All right, some more examples. Now what do we do if there's a coefficient out front? Because you notice this time it's 2x cubed. Well, we just leave the old thing there. You can sort of like, if you're a mathematician, you might think of like, oh, we can move the 2 out in front of the operator or whatever. But another way we can do it is just think of it as, just leave it there. So 2 times, and then if you want to, you can put parentheses just to let you know we're talking about the derivative. But so this 3 goes out in front, then we still have x, and then 1 less power. So 3 goes down to 2. And now we just multiply it out, and we get 6x squared. So you don't actually need the exponent. I'm sure you won't. You don't need the parentheses. I'm sure you won't write the parentheses after you get a little bit better at this stuff. All right, this is yet another way to write a derivative. You put a little prime, and just like we could write down f prime means the derivative of f, little prime outside the parentheses on this means the derivative of everything inside the parentheses. No problem. So power rule, we just leave the 3 alone. The old power was a 1, right? So 1 comes down in front, which who cares? And then x, and then a new power is 1 less. 1 minus 1 is 0. So does anybody remember what x to the 0 is? That's right. Anything to 0 power is 1. So we just end up with 3. So you're actually not going to go through this process. What you'll realize is, hey, anytime x to the first power, the derivative is just whatever's in front of it. So the derivative of 3x is 3. Derivative of 10x would be 10, that kind of thing. All right, last one. Has a fraction in it, but it doesn't matter. You can just leave the old fraction right there and then worry about the derivative. So we're just going to take the 6 and move that out front. Then we got x, then our new power is 1 less than the old power, so 5. And of course, we could simplify this a little bit. 1/2 times 6 is 3. So we get 3 x to the 5th, and we're done. I know I'm hustling a little bit through this, but hey, the power rule, right? No big deal. All right, polynomials. All polynomial means is that there's more than one term. So all the examples I just did were just a single chunk of stuff, right? All multiplied together, like 3 times x to the 5th. But now we got 2x squared plus x. So what's going to happen if you have a plus sign or a minus sign is it's just going to sort of make 2 separate derivative problems. We'll just do each one totally separately. So an x sign just turns into 2 totally separate problems. So first we'll take the derivative of the 2x squared term. So just leave the 2 alone. Then we got to take the old power down. So that gives us another 2. And our new power of x is going to be 1 less than 2, which is 1. Alright, so we did the derivative of this one. Now I got to take the derivative of x. We just take the old power out front, which is 1. And then we got x to the 0 is our new thing, which is nothing. So that's just 1, right? Anything to 0 power is 1. So we get 4x plus 1. Now a mistake that I see students make sometimes is they'll say, oh, x to the 0 is 0, and then therefore this whole term goes bye-bye. Never, just be really careful about that. Anything that has an x in it is going to have a derivative. It's not going to be nothing. The only thing that has a derivative of 0 is a constant, like 2 or 5 or 1 or something. And in a minute, we'll see what happens with negative exponents, but those also, derivative's never 0. All right, next one, we're saying, hey, let's take the prime of everything in the parentheses. Once again, we have two terms, so we'll take them one at a time. First, we have the 3, and then the derivative of x to the 5th would be 5x to the 4th. Just move the old power out front, reduce the power by 1. All right, done with that term. Then the next one is going to be that negative 3, and we kept the minus sign, you'll notice, because that's kind of like just saying, hey, there's a negative 3 coefficient. And then another 3, because that 3 goes right there, so 3x squared. And we just kind of multiply stuff out if we can, so we get 15x to the 4th minus 9x squared. And of course we can't combine any of these terms because it's different powers of x, it's apples and oranges. So that's pretty much the way any teacher would want you to leave it. Last one, decimals, no big deal, still just two terms. So we got 0.5, and then this 2 comes down here, so we get times 2x, and then the new power is 2 minus 1, which is 1. And then minus 0.2 times 3 goes down to here, so 3x squared. So 0.5 times 2 is just 1. 1.0. Right, we don't even need to write it right, it's just a 1, so just x minus 0.2 times 3 is 0.6 x squared. You don't see a lot of decimals in calculus. It's pretty much always fractions. You'll occasionally see pi. Not a lot of decimals. All right, derivative of constants is 0. Now I mentioned this already, but I just want to point out, hey, what do we do if there's a number on the end? So derivative of 2, 0. Derivative of x plus 5, derivative of x is just 1. And derivative of 5 is nothing. So the derivative of x plus 5 is just the coefficient of the x term. This last one, got 3 terms. No big deal, we'll take each one at a time. So derivative of x cubed is 3x squared. Derivative of negative x is just negative 1. And derivative of 15 is nothing. Cool, so you can see how these start getting pretty fast. All right, last slide, negative exponents. So what do? Nothing different, the exact same process. So these can be a little bit tricky to spot. What'll happen more often is you'll get something like this, and you'll want to make the exponent negative so you can take the derivative easily. And that's what we'll do in a second. All right, so negative 3x squared, same old thing. We take the old power, including the negative sign, and move it out front. So that's going to be negative 3. Then we've got x. Now here's the tricky part about negative exponents. We got to take one left. We got to take one away from the old power, right? It's n minus 1. It's the old power minus 1. But negative 3 minus 1, it's not negative 2. It's negative 4, because 1 less than negative 3 is negative 4. And that's the only trick part about these. And then often the directions might say present it as like positive exponents only or something. So you say, you know what? X to the negative 4 is really an x to the positive 4 downstairs. So either one of these is going to be okay. Most calculus teachers are okay with this, but if you really wanted to, you could present it in this sort of fraction form. For this one, we're going to have to do the opposite, because this x squared is downstairs. We can't leave it downstairs. You might be tempted to take the shortcut of saying, oh, well, the derivative of this is just 3 over 2x, because the derivative of x squared is 2x. That is not legal. We have to get it into just like a normal polynomial term. The x can't be downstairs when we take the derivative of it. That would be a quotient rule. That's a whole new can of worms. So what we're going to do is rewrite this as 3 times x to the negative 2. This is algebraically identical to this, except this thing on the right we can actually take the derivative of pretty easily. So at this point, I just keep my 3, move my negative 2 down here, so times a negative 2, and whenever I plug in negative numbers, I put them in parentheses, just so I don't accidentally think I'm subtracting 2 instead of multiplying by negative 2, because that really messed me up. Then we got x, and then 1 less than negative 2 is negative 3. Alright, so we ended up with negative 6 times x to negative 3. Pretty cool. Alright, last one. Wow, this looks like a mess. Alright, they're all negative exponents already, so I'll write it up here just so I have enough space to do a second line. 2 times derivative of x to the minus 1 is going to be negative 1 right here. So negative 1 parentheses times x to the minus 2 plus 6 times negative 2 x to the minus 3, man, minus negative 3 is my old power times x to the negative 4. Because negative 3 minus 1 is negative 4. Ouch. Alright, so this is a mess. Hopefully it fits in here. Got negative 2 x to minus 2 minus 12 x to minus 3. And then these negatives cancel, so we get plus 3 x to the minus 4. Sorry that kind of almost went off the page a little bit, but hey, I've never met a student who didn't go off the page every once in a while, so hopefully he'll forgive me. Alright, so that's what to do with polynomials. There will be some tricks with fractions and roots, so I'll cover that in a different video. But what we'll see is that square root is really just a power of 1/2, so you just treat that as the power rule. Just like this problem, where we took something that looked kind of gnarly and turned it into a negative exponent to make it just a nice polynomial term with no fractions. Same thing will happen with roots and other weird powers. If you're given something really weird, when in doubt, convert it just to an x to an exponent, because when it's x to an exponent, you're in the power rule situation, and that's always the easiest problem you're going to come across.